All right, so I'm going to talk a little bit about BISWeb today. So the title of the session was really introducing a new way to do web native image processing with WebAssembly. We're going to make this kind of partly a demo and partly kind of a conversation about architecture. Feel free to send some messages in the chat if you have any comments or like add something to the Q&A. I can't see it right now. But I think Dustin and Javid will be are both here, so they can answer some questions, and I'll be able to check periodically. So just starting with an overview, BISWeb is a web-based application that's both easy to use but extremely powerful. But you don't have to install anything for this. And there are no servers involved at all. Everything is processed locally on your computer. And the reason we're able to do all this is because of some really great innovations in architecture that Dustin and Xenios, who are the lead developers here, took advantage of. And this enables us to use some really cool features, which we'll talk about in a bit. So we're going to move to this first part, which is really the demo part. And then we're going to talk about architecture towards the end. Here's an intro video if you want to check that out too in the future. All right, so I'm going to bring up kind of two panels side by side. One panel will be this presentation with the directions in case you want to follow along. And the other panel will be BISWeb. So I'm just moving the directions off to the side so you can play along. Yeah, some kind of magic, huh? I just hear comments in the chat that say that it's pretty magical that there are no servers involved. And that is pretty great. Some people were excited about this in last year's Open Science Room because you can do things like, defacing without having to actually give your data to some central server somewhere. You can just keep it all locally on your computer. You can even disconnect from the internet and run some stuff. All right, so let's get started with this part of the demo. And we're just going to open the orthogonal viewer. Or perhaps we should go to the overlay. And feel free to join in on the app. You can join on your computer, you can join on your phone, you can join on tablet. It should work on, we've tested on many different operating systems and devices. So feel free to try to follow along. So we're just going to start. We're going to load some data, and you can just go to help, load sample data. In the future, you can load from the file menu. For now, we'll just load whatever's in here. And so this loads both an underlying image and what's called an overlay image. And as you can see, the overlay image looks like kind of a standard cluster-based analysis results. And now you can play around with it. You can play around with different types of views. So let's make, 5 rows or something, and we can increment it by different numbers. All right, so we're just playing around. We can play around, let's say we want to, decrease the minimum for the overlay. So you can play around with all kinds of stuff. Lots of different visualizations. It's very, we think it's pretty clean. And once you've kind of played around a bit, we're going to move on to this next part called live figures. We're going to come right back to that in a sec. So once you have a visualization that you're excited about, you can actually save the full application state and data into what we are calling a live figure. So really excellent use for this is that you can start doing some visualization and then keep going where you left off. You can also share these live figures with others who can then change thresholds and kind of explore, different slices of the brain, which is pretty neat. So now we're going to go back to this demo and create some live figures of our own. All right, so I chose this view, which I think is pretty cool. I'm just going to save it. I'll just call this test. Sure. All right, so there's the live figure. So let's say that I was just working through a project and I created this visualization and, oh no, I loaded in some data and completely killed what I was working on. I can just go to the live figure that I saved previously and drag and drop it back in. And now we have all the same settings, all the same data all ready for you. And you can imagine this would be really great from the perspective of a collaborator as well. And I have some other live figures I've created from my recent cluster failure, power failure project. So feel free to check that out there. Now I'm just going to check and see if we have anything in the chat. All right, then we will keep moving on. So this next part of the demo is about dealing with clusters. So let's say we have this particular image, which consists of some number of clusters. You can select a cluster size. Let's say we're going to make a really big threshold. Let's make it a little smaller. Then we're going to go and open the cluster info tool. And let's just select again, make sure that we have those clusters. There we go. So this is reporting 2 clusters. Here are the peaks of the first cluster and the second cluster. And you can export these results to a table. Perhaps you're going to choose some different thresholds. And then you want to set the cluster size again. And now we have some different clusters. So you can kind of play around with this as a tool to help you understand what's happening as you're choosing different cluster thresholds or different cluster defining thresholds. All right. So now we're going to talk a little bit more about the image processing functionality here. And for that, we're going to open a different application. So back on the main Bioimage Suite site, which you can follow on here again, you can open the orthogonal viewer for this part. And we'll open some data. For this part, we'll just load some M&I data. And here's all the different kinds of functionality you can do with these images. So we've got, combining images, standard things, cropping, smoothing, etc. We have the defacing thing that people were really interested in last time. We have other functionality that I'll allude to in a bit, like nonlinear, linear registration. So some pretty intensive processes that are all running right in your browser, or really locally, just kind of through your browser. But for this one, I just load in this M&I image, and we're going to do some real-time image smoothing. Pretty exciting. We'll choose some Sigma and we'll smooth. And there it is. Very quick. We have that smooth image done. And you guys can play with the combine. Actually, we'll go ahead and do this. So we'll load as an overlay. We'll go ahead and save this image and we'll load it as an overlay. Loading again that M&I. And we have the overlay as well. And we can see areas where there's overlap in orange. And now we're going to combine these images. And we'll just do a simple subtraction. And here, this is just an image that subtracted that really smooth image from the original M&I. And you can play around with different ways of using these operators. Oh, no, that's just the image in the original image. Let's try that again. There we go. That should be the image and the smoothed overlay. All right, let's move on. This is just showing you a little bit more of all the tools we have. So we're going to skip this slide. And now we're going to talk a little bit about the connectivity viewer, which is a really cool tool that has a lot of new features that are being actively developed. And for this, it'd be great if we could bring Javid on. Thank you guys for your comments. Yeah, we think it's really neat too.
Javid, could you just give me a little wave in the chat so I can see your little avatar? Or alternatively, Dustin. There we go. Thank you very much. There we go. Inviting you on now.
I'm just having fun flipping the image around.
This is so cool. I'm so glad I'm awake for this.
Thanks. Yeah, it was all the brainchild of Dustin and Xenios, so it's
Awesome.
really phenomenal.
Slick is the one. All right, I'll be quiet again.
Thanks, guys.
You guys see me?
Yep.
I'm going to share my screen.
Yeah, I will stop sharing.
Okay. Okay, so I'm not sure if that share button up there should work, right? Embed share to, no, okay.
Yeah, you should be able to just the screen share button, like little square with corners on. If you hover your mouse over your picture.
Yeah, like when I'm clicking on the share button, I see like share like in Twitter, Facebook, and LinkedIn. This is different. So
It's like a focus screen, so you see there should be a mic, video, and like a cross.
okay, click. Oh, I see. Wait. Share screen. Awesome. So
Yeah, there.
Can you see? Can you see now?
Yeah, we can see you.
Awesome. Okay. So good night for people that are in the East Coast, or good morning for the other people. So I'm going to talk a little bit about connectivity viewer. So connectomes are widely used in neuroscience, but however, visualizing them can be very difficult. For example, if you do have 268 nodes in your atlas, you will end up with 35K possible edges. Here, as a part of BISWeb project, we developed a connectivity viewer panel which show you visualization of your connectome in 3 different layers. First, in circle plots, we are going to show you edge level visualization of your connectome. Then in surface plots, we are going to show you the node level, and at the end, we are going to show you network level visualization. So as an example, I'm going to load a sample matrix which has both positive and negative edges. So save the origin. So feel free to ask question. I assume that you know about positive and negative matrices. So positive matrices are like, for example, matrix is a matrix that has positive correlation with your, for example, behavioral measure, and negative matrix is the matrix that has negative correlation with your behavioral measure. So this is the circle plot. So you can focus on one single node, or you can visualize all edges. You can just focus on positive or negative or both together. You can put a threshold here, like higher threshold, which end up with like a lower number of edges, and lower threshold, which end up with a dense circle plot. And then you will see this balls and stick plots in the surface plot here. So let's focus on like I'm going to this node all threshold is high, so display now. So there's a way to just remove these balls and a stick plot. I'm going to get back to it later. Let's focus on like a chord plot for now. So the chord plot shows you the correlation of different networks in your brain. You can like focus on one of those networks, and then it will show you the connected networks in your brain that has correlation with that specific network. And then you can also click on the summary matrix, and that will show you the number of edges that are between the appropriate networks in the summary matrix. You can also screenshot and like this one. And then export all different views of your like surface plot. So let's get back to this, and I'm going to oh, here we go. So once you created lines and you do have circle plot on the left and the surface plot on the right, you can just click on the threshold by and focus on positive or negative one, and then clear the lines, and then like see the surface plot, and get rid of those balls and stick plots. So we provided 3 different atlases, 268 chain atlas, 368 chain atlas, and AL, and one for mice. So all this panel is developed in JavaScript. So you don't need to install any single library. All you need to go to the connectivity viewer panel and then upload your positive and negative matrices here, and then follow the instructions as I talked right now. So let me take a look at the questions here. I'm unsure what file type connectivity viewer takes. I think I missed it. Okay, so the format of your connectivity matrix is a binary matrix, which is in dimension of your atlas. For example, if you are using 268 by 268 chain atlas, so you will upload a 268 by 268 binary matrix, and then you upload positive and negative matrices separately. Could you describe the data which you load to view the chord plot? Describe the data which you load to view the. Okay, so for the chord plot, I haven't uploaded any separate matrix. All I uploaded is just this positive and negative matrix, like this sample one. And then once I plotted this circle plot, so I am able to use chord plot as a kind of one further summarization step after that. So you are not involved in these steps. It's being done behind your browser. So we already embedded the code that which of those nodes, which of those 268 nodes are belonging to these 10 different networks. So you don't need to worry about that. TXT, yes, it should be TXT file or .csv file, like comma separated values. .csv file. Cool. Thank you. Thank you, Rachel. Thank you, Paolo. So, Stephani.
There's also a couple of questions in the ask a question box, Javid. I don't know if you want to address those now or come back to them with someone else.
So, wait, is there any new questions?
I haven't been following this chat, but the thing about it making the reproducible, so algorithms change, get fixed, etc. How can we make the analysis or visualization reproducible with stock BISWeb instance? And Stephani and Jarek have been having a good old chat about that. I'd love to hear a bit more about that if you want to talk about it with your voices. We can check on it.
Kind of difficulty understanding this question. Probably Stephani will explain about the reproducibility, but yeah, let's wait for a step about that. So,
Hey all, I'm just here to say that we're gonna talk about the regression testing in a bit, and we can answer Yarik's question maybe in a little more detail then. And we will talk. I guess we kind of skipped through that slide that showed different types of data that were used, but so far we've been using it primarily for MRI and fMRI and calcium imaging in rodents. So human and rodents and MRI and calcium imaging. Theoretically, it should be able to take any type of nifty file. And I'll just bring myself away.
On connectivity viewer so far?
Yeah, I think perhaps you got all the connectivity viewer questions. So if you're done with the connectivity viewer demo, I can bring it back to the original presentation.
Go for it. I think I'm done. Like, if you have any question, you can email me after and how to use that or any question related to that.
Yeah, Javid's been doing a lot of awesome work on that. So definitely shoot any questions his way. Thank you, Javid. All right. Cool. So we're going to go through a little bit more of the demo, and we're going to talk about architecture in just a sec. All right. So I guess we're talking. Ooh. Yes. So we're talking about regression tests right now. As a matter of fact, we're going to go back to the original BISWeb suite. And here I'll just pull this aside so you guys can follow along. So to run some set of regression tests, for instance, let's say we want to run some tests that check whether the display, the objects that we display at the end of some set of changing some set of parameters look the same as, say, in a previous version of the software. We have kind of a gold standard that we're keeping kind of constant across versions of the software or across changes within a particular version that you can always compare to that latest version. So here's a display test. I'll just make this a little bit bigger. And we're just going to run a ton of tests right now. So here we go. You can see the results compared to the gold standard. And we also have some tests where we want to see that they failed. So we have, a bunch of tests that should pass, and then we have tests that should say failed at the end of the tests, just so you know. But I think we indeed have a mix. And you can also run regression tests for individual modules. So here's for the display. You can see the details down here that we can use to kind of address certain changes that we see. Some changes may be expected or intended, and some may be problematic. But let's say that we just wanted to run for a module like smoothing. Here's the module regression tests. And let's just, what's kind of an easy, let's see. Here we go. Yeah, so let's go ahead and run this. All right, cool. So we passed a couple tests and we intentionally failed one, which is great. So you can go through, if you're more developer-minded and you create your own new modules for BISWeb, you can also create your own regression tests. And those will kind of stay with BISWeb throughout, updates. All right, so let me just see. Cool. Dustin and Yarik have been having an awesome, detailed conversation, the questions and answers. So feel free to check that out. I think that I'm not going to go into it just right now in the interest of going through the rest of the presentation, but if you guys wanted to come on later and chat, that would be really great. All right, so let me just see. So far, the tools take too many resources. Javid, do you have a tutorial to make a binary matrix? So really, anything, you could use MATLAB, you could use Python, you could use whatever you feel like. All you need to do is save, a file that has ones and zeros, that has, X, like 268 for now, rows and 268 columns. So really anything you want that can make a binary text file, that's what you'll be using. Let me just see if I got this. Yeah, and you can threshold any matrix. Way to apply the same processing across multiple subjects. No, that's a really good point. So we're going to talk about the command line version of these tools in a sec that are installed using Node, the Node package manager. And that you can really put together in a traditional command line, processing of multiple subjects. The web version right now will, it's kind of been in the back burner to try to process multiple subjects, but it seems more natural to use the command line tools for that. So that may stay in the back burner. Yeah, thank you for the questions, by the way, guys. This is really great. All right, goodbye regression tests. And now we'll talk a bit about the architecture. And again, this is really the brainchild of the developers. So if you have very deep questions, I'll try to answer as much as I can, but they may have some answers for you too. All right, so we start with a set of algorithms that's developed for us, for the majority of the functionality that we have is in C++. And then those functions are compiled either to WebAssembly or to a native shared library. And most of our functions will be compiled to WebAssembly. And just a note about WebAssembly, it's something that makes languages like C++ usable in the browser. And compared to, let's say, a native C++ application, if you were to rewrite that functionality in JavaScript, you might get approximately 50% of the speed that you would have with the native application. But with WebAssembly, we're seeing about 90% of the speed of a native C++ application, which is really cool because nobody has to install anything to get that sort of functionality, to get something that runs just as quickly as a natively installed software. So once you have the C++ functions compiled to WebAssembly, there's a data serialization layer. I'm just going to note that, but we're going to skip past that. Then you can create a wrapper layer in JavaScript around those functions, and then you can use, and those WebAssembly functions are accessible to JavaScript. So then you can use that directly from JavaScript and feed that into whatever web-based application or desktop application you're going to use. And then also we use that in our command line tools, which I'm going to talk about in a second. You can also, okay, so really quickly, another highlight, like I said before, nobody has to install anything. If you use the web-based tools, you just go to the website on your phone, on your tablet, while you're eating dinner, you can just pull it up on your phone. It's really fun. And there's no servers. All happening locally. You can disconnect from the internet and still run. But you can also use this functionality in MATLAB and Python for now. And perhaps there will be other ways that you can use it. Basically, anything that could use WebAssembly should be able to access the functionality. And we'll look at an example. So here's some individualized parcellation code that was created by Merave Salehi for her paper. And we're able to call that in MATLAB, Python, and JavaScript. So here's an example of how you would call it in JavaScript. You set, the input parameters, just some structure that holds input parameters, and you pass it to this, this wrapper, basically. Here's what it looks like in Python. Again, you see that one line input parameter, or like here we separate into multiple lines, but it could be just one line of the input parameters. And then the next line is just calling that functionality from WebAssembly that's been compiled for Python. And then here's an example in MATLAB. So you get the theme. Again, we're just setting those parameters and you're passing it to this one function. So this is just an example of how simple it can be to call kind of the same function, the same underlying functionality from 3 different environments. All right, so now we'll talk a bit about the command line tools. And I'm just going to pull this to the side again in case anybody is excited about installing some tools with me. So I actually, believe it or not, I already have these tools installed, so I won't reinstall them. But you guys can go ahead, just run, npm install BISWeb node. Should all be packaged for you. And then once you have it installed, here's just the smoothing, and I'm just bringing up the help. So here we go. This is how you can use it. And this goes back, Suichi, to your earlier question. You can just use this as, a standard command line to pipeline. And here are those regression tests. And there it goes, it's chugging away. So I just told it to run, basically it starts at test number 0, and I told it to run until test number 20. And you can set the binary flag whether or not to run it. So I set that. So it's just running those 21 tests. Cool. So just showing you can, run those regression tests in the web, which is really neat, or here in the command line. And I'll just let that do its thing. Oh, it's done. Good for it. All right, and a final note, we're welcoming contributions, or if you have questions, feel free to reach out to us. You can find a ton of resources on our documentation tab of the main web app. Just to be super clear, that's just right here. So we have YouTube tutorials, we have user-oriented documentation, we have developer-oriented documentation, and we have a few other resources for people. And here's the repo. All right, so thank you to the team. So Dustin, Xenios, as I keep saying, are the brain people behind this. Javid, who came up and spoke earlier, Zach, Cheryl, Haley, and John, and our funding. That first one is the funding for the BISWeb project. All right, we're done. Thank you guys for hanging out with us. Now we can kind of have a conversation about anything you guys want to talk about. And I shall stop my screen share. How do I do that? There we go. All right. Oh yeah, so Paola, yeah, no install. You can just go to the website. If you feel like using the command line tools, that's where you'd want to install it with npm. But there's no need to do that unless you want to, build a pipeline with multiple subjects. But you can just go to the website. You can just, load in an image and let's say deface an image like that, if that's what you'd like. No need to install. Absolutely. Yep, Yark, yeah, you're right. So Suichi, you're asking whether the commands run in a single thread. I'm not sure in which context. Do you mind elaborating a little bit? And I don't know, we could probably bring on people if people wanted to have a conversation.
Sure, yeah, we've got room for 2 more people. If anyone else wants to come on, maybe give us a wave in the chat and I'll send you an invite.
And, oh, okay, if we're talking about, yeah, I see Dustin's comment there. If we're talking about whether we can do things in parallel, I think it's possible to set that up. I think a lot of the functionality right now is set up to run single-threadedly. Dustin, if you'd like, you could come on and talk a little bit about the possibility of that functionality. It's up to you.
Justin doesn't want to come on screen.
Cool.
That's
Sounds
cool.
good. I'll just hang out right here. You guys can look at my face. Cool. So I'll just hang out here. I'll keep monitoring the chat for any questions. Oh yeah, Paola. Could we bring Paola on?
Hi,
Hey, how's it going?
I'm not sure how I look. I'm not, this is morning here, still having the coffee, but nice to meet you.
Good to meet you too. Thank you for your enthusiasm in the chat.
Well, enthusiasm is because fundamentally I've been trying to do some work. Starting in neuroscience, coming from systems and artificial intelligence, system design and stuff. And to look at neuroscience, it now is like, I think I said it before, it's a massive headache for a number of reasons. Like, I'm not a neuroscientist, and I said, okay, I'm going to learn neuroscience first, and then I'm going to start working on the research or some experiment. But the learning neuroscience is not straightforward. You can learn neuroscience from a medical point of view. You can come from them, but that's kind of going to be different from, I don't need to learn the whole neuroscience body of knowledge to maybe work on a specific issue or question. So it's becoming, and then of course, the moment you start working with the tools, you have to learn Python, there is data fragmentation. Stephani and Jared, I gave a little talk last week about the need for high-level tools and high-level, representations of neuroscience data, so that I don't need to study the whole body of knowledge to be able to carry out one simple task or a query or try to answer a question. At the moment, there are so many obstacles just to do a little bit of research using neuroscience. And so I think your tool definitely goes in the right direction. It's a revelation for me in many ways, and I'm gonna really, so I resonate because it takes the system view, which means it gives me a single point of entry to navigate the data. I'm not scared by complexity at all. I'm interested. I want to look at the details and drill things down, but starting from the top level view, drilling down, I can figure it. So I can relate to the way my brain processes information. What I cannot do, and I have seen, is quite the opposite. People start approaching topics from the lowest level, the most fragmented, and that's what gives the people headaches. And it's not only me, but it's a lot of neuroscientists, a lot of people who do not have a software engineering or programming background. So they're actually also suffering from that. So thank you so much for this. I will study, use it, and get back to you.
Awesome.
And yeah, thank you so much. I wanted to say this, I thank you for bringing me up, Cass, so that I met these people. And do you have any questions for me, or is there something you want me to say in relation to what I've seen today? Do you need any feedback?
So first, to what you've said before, I'm glad you find value in this. Yeah, we think that there can be a really big barrier to access for a lot of groups to get started with neuroimaging. If you have to, if you're a first year grad student and you have to come into it knowing, how to use Bash and how to use maybe Python or MATLAB or something like that, it can be a little challenging. At the same time, we do want to enable developers to develop like really robust, really valid state-of-the-art tools in this framework. But we, at the same time, on top of that, we want to be able to make those really state-of-the-art tools accessible to users. Because what good is a tool that improves sensitivity and specificity if users can't get their hands on those tools? I think that it's a really important way to lower barriers to access to a lot of people, while at the same time trying to promote our values of reliability and reproducibility. Sure, and if we're interested in hearing any feedback you might have, if you go through and play around with the tools. Please let us know if you have any feedback, anything, even user experience or UI considerations. We'd love to hear it. We're always interested in hearing people's opinions and thoughts when they're going through our software.
Thank you. Let me ask a quick question about this containerization trend. So I've been looking at containers because that's what people have been using. And that, again, has become another learning curve. Before I can get anywhere near the neuroscience or the neuroscience data, I need to get to grips with the containers, which are themselves a barrier because there are issues. So does your system not relate to the containerization at all, or does it relate to containerization in any way?
So I will say there are many different ways you can use and develop for BISWeb. We imagine for most users, or for a very big segment of our user base, we imagine people will come on to the web-based software, and you don't have to install anything, you don't have to interact with containers, you just have to do the point and click that I was doing earlier. For developers, we do have a containerized version of BISWeb just to facilitate development. If that's something that a developer thinks would be useful, and I found it useful for myself as well. But no, many users will not have to interact with any containers, just if you really feel motivated.
That's such a relief. Thank you. And so basically, your software consists of pointing, processing, and visualizing the data in. This is what your system does, essentially. Am I right?
Yeah, so processing, we have a lot of processing functionality. So the one functionality that we're still building out in the web-based software is some statistical functionality, but then we have the visualization, post-statistical analysis, that's already there. So yeah, I think that you could summarize it that way.
Thank you so much. Thank you, Jared. Thank you, Stephani. You can. I'm done. I just wanted to say hello.
Thank you for coming on and hanging out with us.
We'll connect.
About the connectivity here also.
So at that point, if anybody else, I'm just gonna sit here and hang out. If you guys let me know in the chat if you want to come on, and I'll just hang out. Otherwise, you can chat. Let us know if you have any questions, and we'll answer them like this.
Hey, I'm going to take a cheeky question if I can.
Yes,
so you mentioned about like barriers for students and stuff. I'm just wondering, and obviously you've got the command line sort of higher end. I'm wondering who your like primary users are and who you think this tool is most useful for. Like I like the idea of having something to make some visualizations for figures as well, but then I'm kind of interested in what Jarek was saying about how do we reproduce this figure and stuff like that. So just wondering, like, who is this for? Who is the best person this is for?
Yeah, definitely. So there are two different answers to that question. That's who are our users right now, and who do we want our users to be? So right now, since this is kind of a growth out of the traditional Bioimage Suite web software that we're calling the legacy version of the software, that was a fully a mainly kind of command line tool used in the lab, in some of the labs at Yale. And it turned into this beautiful BISWeb project that's a web-based software. So, but most people are using BISWeb for processing, probably more so at the command line level at Yale. And then we see a lot more people using it for visualization at this point. But our intention is that we have all the same functionality. We have all the same kind of heavy duty functionality to do a full processing pipeline. So we're hoping that we can appeal to a wide range of users, people who want to do a full processing pipeline from the command line. We have those node tools. If we want to introduce somebody, or maybe you have a few subjects or you have really specialized needs, you might want to use the web-based software. You could work with us, or you could develop your own tool to have accessible to the web-based software. And that might be more of kind of a novice user who wants to be more familiarized with these tools. So right now we're thinking of the processing functionality a little bit more geared to, in the web, a little bit more geared to the novice users, but we really want the command line tools to be available to anybody who wants to do a serious heavy duty processing of their data set. And just to the reproducibility question, because you were asking that, those regression tools, the fact that we've built them into the web-based software and the command line tools, it's just kind of trying to hammer home the point that we really want them to be reproducible within version updates. We're also working on including some benchmarking analyses so you can assess, let's say, sensitivity and specificity of some, for my project, some cluster-based inference kinds of methods. So we're really hoping that this can be a tool that helps promote reproducibility in many different ways.
That was really cool. I love the sort of journey, the story of the journey of how it's developed from like this really heavy thing into something that's much more friendly, and it's nice for a lot of people.
Yeah.
I had another question, but it's totally gone.
Yeah, no, but based on what you were just saying, for instance, we had some people interested in creating state-of-the-art calcium imaging kinds of analyses, and those have been built out into BISWeb as well. So it's just a way of allowing us to have these state-of-the-art analyses, but not something that only extremely technically sophisticated users have access to, because we want to have, you know, the most robust state-of-the-art tools available to anybody.
And you mentioned that like if you want to develop your own little plugin type thing, then you might be able to help us out with that. What
Definitely.
kind of support? Like, it's free. That was my other question, was about the data.
Yeah.
So it's free, right? So what kind of support can you give people? Is there like an open source development like team and we can just like chat with loads of people, or is it like driven by a company and there's going to be full-time people there?
Nope. So this is available under the GPL. I think there's one part of the software, Dustin, you're going to have to let me know which one. I think there's one part of the software that has a slightly different license, but the idea is that the whole software is open. You're able to take it and do what you will with it. It's on that GitHub repo. You can reach out to any of us here. I'm happy to field any questions about this, and we'd love to provide support for developing out anything that you'd like. I will say that we have some other projects that we're working on right now, so that will kind of limit the amount that we can help you. Oh, Dustin's saying some of the registration code is under a different license, so just keep that in mind. So if you're building a module that doesn't use the registration code, then I mean, you're fine. But yeah, so you can just reach out to me or to any of us, and we'd be happy to support you as much as we can, considering that there are also some other projects that we're working on right now too.
Awesome. And there's some cool stuff as well about the data not having to leave your machine to do this visualization. So like it's a nice way to like share a like live visualization with someone. Like you can do a screen share, but you don't actually have to give them the data. And you know, you've got this issue about like sharing data and moving it in places. That's kind of not going to be as much of a problem or a different consideration. It's very cool.
Yeah, definitely. People were really interested in that last year for clinical data, because you don't exactly want to be putting your clinical data up on some random server. Yeah, but yeah, you can just, so Dustin was saying it again, you can just use it without the internet. You can just open the website, turn the internet off, and it will still run. It will still have all the functionality available to you.
And great for student demos as well. I'm thinking about like times I've had to make sure MATLAB was installed on 20 machines, or like everyone's got the right version of FSL. I just send them to the website.
Exactly. And I think that's a really interesting point, because a lot of people say, you know, I don't know whether this demo, you know, doing a live demo is not very safe. You know, you might run into some technical difficulties, but I know I've tried this a million places. I can always boot up the website, load some sample data, and it works almost everywhere.
Amazing. Right, I'm going to duck out. We've got just like 6 more minutes, and I think there's another question in the poll, so I'm going to duck out.
Oh, is there another question? I missed that.
Thanks very much.
Let's check it out. Hey, another Yarrick one. Awesome. Could it be used server side? Dustin's saying it works on your phone too. Yeah, phone, tablets, everywhere. Yeah, could it be used server side? Data's on the server, browser's a client, processing happens on the server. Yeah, we have things set up right now. Dustin could talk a little bit more about this, or you could write in the chat. Right now, there is some functionality to pull data from the cloud, but I can't speak at length about that. I don't think right now we're having storage. Okay, just computationally expensive stuff.
Mostly is in JavaScript, not JS, not C++. but some of them that are computationally expensive, we are using WebAssembly.
Oh, that's what Dustin was responding to. Yeah. So things like the nonlinear registration is going to be a C++ module. Smoothing, yeah, smoothing is done in JS. Although I did see also there's an old C++ smoothing module in there, but we're using the JS version. Yeah, it's neat to be able to have some really intensive C++ functionality that, you know, if you were to translate it fully to the web, would run really slow, run almost as quickly in your browser. Cool. But back to Yarik's question. Yeah, Dustin, if you'd be willing to provide a little note about Yarik's third question, or the third question, which is from Yarik, just talking a little bit more about how integration with the servers could be possible, or whether it is possible. I know we have a little bit of cloud access right now. I don't think it's fully deployed yet. Oh, he did write about it down here. Sorry about that, Dustin. I totally missed it. So he's saying the data has to be serialized and deserialized. So nope, he's still talking about the speed. Okay, I'll just read out Dustin's answers from the comments. So he says we have some code to interface with a server or a S3 bucket on Amazon, and does just what kind of Yarik was talking about in that question, which will read and write to a server, but still process the data locally. But we're still exploring because browsers are difficult for saving multiple files. Thank you for answering that one. Semver or Calver? Okay, cool. I will copy that. Yarik is suggesting that we check out Semver or Calver. Let's open some notes. In this last kind of few minutes, people feel free to shout out. I mean, like send out a chat if you have any questions. I'm just going to keep poking around at BISWeb so you can see a little bit more of what's going on. All right. Documentation. So here are all the applications. We also have a pretty cool, simple MNI to Telerik viewer. You got some stuff in MNI and you're wondering where they are in Telerik, you are in luck, along with the areas that they're called. All right. Here's that dual viewer, the registration stuff happens here. Yeah, the defacing tool is really fast. Isn't that cool? It's really neat. All right. Show access to data in datasets.data. Okay, let's do it. WebAssembly, the magic of WebAssembly. Yeah, Dustin was pointing out above that the defacing tool is a mix of JS and C++. But it's a matter of just doing, you know, registration to a mask, basically, and then masking. Oh man. Yeah, we have some native linear registration and nonlinear registration here that comes from Bioimage Suite. AAL Atlas. I'm not sure where that is. It could possibly be in the connectivity viewer. Let's see if it's in MNI to tell. No, I'm not seeing it. Yeah, I will check that out in a sec. Okay, datasets.datalab.org. Thank you. So I'm not sure where we put that, or where you put that tool. Is it? Yes, you'll have to remind me, Yarik. Oh, we did it. Okay, cool. Oh yeah, you know, Xenios did. Xenios put that together. I'm not sure. I don't have that locally. I think that's a Xenios has the ownership of that kind of thing. Thank you, Yark. Yeah, if you can pull that up, that would be really cool. That's just showing how we can pull data from DataLad and like look at it and like use it, do whatever we want in BISWeb. And we're appreciating love. I know we're getting kind of a minute over, and I just want to say, please, if you have any questions, you want to just have someone walk you through like the repo or something like that, just reach out to us. We would be super happy to talk about that. I think, yeah, I'm pretty sure there was an AAL atlas on the connectivity viewer. Perhaps I'm confused. Yeah, here it is. So that's one of the 2 parcellations that we have available for the connectivity viewer.
No, actually in the alpha app, so this one is the main release, but in the alpha app that I was showing, you have like 3 different atlases. Yes. And
yeah.
one.
I think there's also a possibility to, yeah, in this version, you can also import your own parcellation images. That's still a little bit in development, but yeah, feel free to check this out. The Allen Mouse Atlas. So for mouse people, there's probably a lot of human people here, but mouse people, that's a possibility. Thanks, Paul. Okay, cool. We are going to click the DataLad stuff because it is so awesome. Let's open this up. All right, we're going to connect to DataLad. Let's do somewhere that I can see, let's see, derivatives. All right. Good old bids. Okay, cool. Perhaps that one. All right, so this is something that we haven't really fully tested out here. I know. We got it to work one kind of cool power session with Yark and Xenios. Oh, ones that you hosted? Okay. The Haxby? Let's do it. I'll just use your built-in tool. Haxby.
Let's go back to the URL.
Labs. Thanks. Oh, I see. You helpfully color coded it for us so I could make my life easier. All right. All right, let's check this out. Shall we do some derivatives? Research? Or nope. Let's just do some. Let's just do the subject's data. Let's do anatomical. That seems more reasonable. All right. Let's try to connect again. Should I put the full guy here? Probably. All right, let's give this a shot. Thanks, Yark. Oh, I didn't see the one above. Okay, cool. So thank you for helping me figure this out. Okay, cool. So we've imported, I think, this attention data set from Haxby.
We're running out of time. If anybody needs to leave, feel free. Just
all right. I wanted to let that DataLad bit happen and we can go, yeah, that works. But yeah, we're a little over. I'm happy to let this run on a few more minutes if there's anything you want to close with. And it says, so we have got a Mattermost channel for this if you folks want to use it, or I'm sure you have your own ways of connecting with each other as well.
All right, let's see if we can get this to happen. There we go. Okay, cool. Thank you, Yark. Yeah, that was a good one. So this part of this, just so everyone knows, this is like super developmental. So like we kind of, rather Xenios kind of put this together, and we haven't really fully played with this, but it's really awesome that we're seeing, the structure and stuff. Let's see if I can get into this subject, the structure of this. Yeah, so I may have a little bit of difficulty doing this part myself. Sorry, guys. But it's not in the official release. No, Yark, thank you so much. I mean, this is a really cool function. I'll just familiarize myself with this next time, and we'll kind of test it out before I do it in a live demo. But you can, so this kind of illustrates Yark's point. You can actually interface with other sources of data. That's what this kind of toy example, that's going to be really cool once we release it, illustrates for everybody. All right, let's give this a sec. Connect. Cool. All right. Oh my goodness, I think it's happening. There we go. I know the suspense was killing everybody out there. All right, we're loading. Oh no, I'm sorry, I loaded a bold image. Let's not do that. Okay, well, I guess that's what we're doing. Cool. So yeah, thank you, Yark. That was exactly the right one. For people who are kind of watching at home, we pasted this. Oh, no, we didn't paste anything. We just hit connect to Data Lab, no URL. We hit OK. And then it populated, I think, for as a default, the Haxby attention data set from this subject. And then you have the option to display whatever you've selected as an image, as an overlay, or as the second image or second overlay, since we're in the registration viewer. Yeah. This really isn't something that Yarek, I saw your comment. This isn't something that I personally have played around with a lot, even though I think it's amazing. So yes, it would need more testing by me. Yeah, Paola, this should happen in your browser as well. And I see the argument was given up here. So I think, why don't you go ahead and give this a shot? With interfacing with this data hosted on Data Lab over here. So theoretically, you should be able to, if you're hosting data elsewhere, you should be able to bring it right into BISWeb. If you want people to see, products of an analysis, say, you could really easily make that available to anybody. And we'll just take, let's say let's take the defaced mask and put it as an overlay. All right, so that's just a mask. This isn't an actual image. Let's do this guy. Now we're just playing around here. Cool. So Cass, if we're going over time, I think we've accomplished the awesome Data Lab BISWeb reunion. Just let me know if you have to switch to the next session. If not, I'm just going to keep playing.